Hey guys, how's it going? In this video we're going to go over 4 worked examples to show you how to do problems involving phase difference. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1 says describe what is meant by the term phase difference with regards to waves. Well, remember from the notes that phase difference describes how in tune two waves are. And we can say that it gives a measure of how much one wave lags behind another, or one point lags behind another on the same wave. Question 2 says 2 points in a wave A and B are separated by a distance of 4 centimeters. If the wavelength of the wave is 10 centimeters, calculate the phase difference. Well, let's write down what we know from the question. We're trying to find the phase difference phi. We know that x is equal to 4 centimeters, which we need to write in meters as 0.04 meters. And then the wavelength lambda is 10 centimeters, which again we need to convert into meters, which gives 0.1 meters. And then we can write down our equation relating phase difference and wavelength. So we have phi is equal to 2 pi x over lambda. Substituting in the numbers gives 2 pi times 0.04 divided by 0.1. And putting that into your calculator should give you an answer of 2.5 radians. Question 3 says a travelling wave has a wavelength of 60 millimeters. A point P is 75 millimeters from the origin and a point Q is 130 millimeters from the origin. Part A says what is the phase difference between P and Q? Well, let's write down what we know from the question. We're trying to find the phase difference phi, and we know that x is the distance between P and Q, which is 130 minus 75. Because remember, point P is 75 millimeters from the origin and point Q is 130 millimeters from the origin, so the difference between the two must be 130 minus the 75, which gives an answer of 55 millimeters, which we can rewrite as 55 times 10 to the minus 3 meters. And lastly, the wavelength lambda is 60 millimeters, which we can rewrite in meters as 60 times 10 to the minus 3 meters. So writing down our equation, we have phi equals 2 pi x over lambda. Substituting in the numbers gives 2 pi times 55 times 10 to the minus 3 divided by 60 times 10 to the minus 3, and putting that into your calculator should give you an answer of 5.76 radians. Part B then says which of the following statements best describes this phase difference? Justify your answer. So is it almost completely out of phase, roughly a quarter cycle out of phase, or almost in phase? Well, we said that P and Q are separated by 55 millimeters, which is almost one wavelength, i.e. 60 millimeters. So therefore, we could say it's almost in phase. Now, there's 2 other ways you could think about this. So we could think about the answer in degrees as well instead of radians. So if we were thinking about degrees, 5.76 radians is 330 degrees, which is close to 360 degrees, i.e. the value for one full wavelength. Or if we were to write our final answer for phase difference before for part A in terms of pi instead of 5.76 radians, then that's the same as 11 over 6 pi, which is close to 12 over 6 pi. And we know 12 over 6 pi could be simplified to 2 pi radians. So we're close to 2 pi radians, which means it's almost in phase. So that's just a few other ways to think about it. Lastly, question 4 says a wave has a speed of 350 meters per second and a frequency of 500 Hz. 2 points in the wave are pi over 3 or 60 degrees out of phase. What is the closest horizontal distance between these 2 points? Well, first we want to find the wavelength lambda, so let's write down what we know from the question. We're trying to find lambda. We know that the speed v is 350 meters per second and the frequency f is 500 Hz. So we can use our wave equation v equals f lambda from National 5 and Higher Physics to find what lambda is. So let's substitute in the numbers to get 350 equals 500 times lambda, and then to get lambda on its own we do 350 divided by 500 in your calculator, which should give an answer of 0.7 meters. Now that we've got the wavelength and the phase difference, we can calculate x. So it says now calculate x. So if we're trying to find x, we know that phi is pi over 3 radians and lambda is 0.7 meters. So writing down our equation for phase difference, we have phi equals 2 pi x over lambda. Substituting in the numbers gives pi over 3 is equal to 2 pi times x over 0.7. Notice how the pi's will cancel out from both sides, so that's the same as writing a third is equal to 2x over 0.7, and we want x on its own, remember. So let's cross multiply here to get 3 times 2x gives us 6x is equal to 1 times 0.7, so that's 6x equals 0.7, and then to get x on its own we divide both sides by 6 here to get an answer of x equals 0.12 meters. That's all for this video, folks. I hope you found it useful. If you did, give it a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.